Okay, let's have a second example of the ideal gas law. So let's first again write our equation. PV equals nRT. Now it says a tank with a volume of 658 milliliters. Okay, there's our volume, but that's in milliliters. We have to use liters with the ideal gas law. So 0.658 liters is our volume. It contains 1.50 grams of neon gas. Okay. In the ideal gas law, we don't have anywhere to put mass, but we do have a place to put moles. So we can change this 1.5 grams of neon to moles by dividing the mass by its molar mass. Okay, which is the mass number from the periodic table. For neon, that's 20.1797 grams per mole. So that will give us our moles there. Now, we have R, but let's continue to read to figure out which R constant we should use. The maximum safe pressure that the tank can withstand is 4.50 times 10 to the second kilopascals. Okay. So we can use pressure in kilopascals here in the periodic, or in the ideal gas law, 450 kilopascals. Now, in most chemistry textbooks, they show this ideal gas law, and they'll give you two values for the R, for the universal gas law constant. They will often give you the 0.0821, that is liters, atmospheres, moles per Kelvin, so pressure is being measured in atmospheres. They will also give you 8.314 as an R value, and that is when the pressure is measured in kilopascals, because kilopascals is a really common pressure unit of measurement. So you will often see 8.314 as an R, but notice the pressure is measured in kilopascals, so these must match. And then finally on this question, at what temperature will the tank have that pressure? So we are hunting for temperature. So to solve this, we need to go 450 times 0.658. Okay, it comes out to be 296.1. Now I'm not going to control anything on sig figs until the final answer. And then let's solve this quantity. So 1.50 divided by 20.1797, that's going to give us our moles. I'm not going to round that off yet because I don't want to double or triple round through this problem, and then times it by 8.314. Okay, so I have 0.617997294, so I've got quite a few extra digits there. And temperature, now we'll divide both sides by this quantity here, the 0.617997294, to isolate the temperature. Okay, and so our temperature comes out to be 479.1 Kelvin. Now with sig figs, we have 3 sig figs in each one of those quantities, so we would round this to 479 Kelvin as our temperature of gas. Okay. So PV equals nRT, the ideal gas law. Always pay close attention to the pressure so that you'll know which R constant to use, the kilopascal or the atmosphere value. Make sure that your volume is in liters, and then N is representative of moles, so you may have to change the mass sample to moles as we did in this example. Okay? And temperature will always come out in Kelvin.